So let's do another example. So I'm going to keep the same claim as I had before. So I rewrote it just so we won't have to look back at the other video. So the claim is that chocolate bars have a mean weight of 53 grams and a standard deviation of 7 grams. So we do a different experiment this time. This time we purchased 150 chocolate bars. So last time we only purchased one chocolate bar. This time we purchased 150 chocolate bars and they have a mean weight of 52 grams. And so the question is, and I've made an official question this time, with a confidence of 95%, can we reject this claim? So have we gotten enough evidence over here to reject the claim over here with a confidence of 95%? Okay, so what do we suspect? So we suspect that all right, so our mean is 53. Our evidence was, our experiment was 52. So we think that the actual mean is less than 53. So we think that the mean is less than 53. So let's actually do the math. So what we know is, we know that originally we thought that the mean was, well, the claim was that the mean was 53. We suspect instead that the mean is less than 53. The significance, so we want to be, what did it say? We want to be 95% confident. So that means our alpha is going to be 5%. The standard deviation, now what we have is we took the average of 150 chocolate bars. So it's going to be the standard deviation divided by the square root of n. So the standard deviation was 7 divided by the square root of 150, which is going to be 0.57, doesn't really matter, which is 0.57. Okay, now which probability are we going to find? Because our experiment was less than the mean, we want to find the probability of it being 52 or less. We're going to find this tail probability over here. So we want the probability that x is, technically we want the probability that the mean was less than 52. So we're going to have to do a z-score calculation. So the z-score is going to be 52 minus 53 divided by 0.57. So 1 divided by 0.57. And that's going to be 1.75. Negative 1.75. So the probability that the mean is less than 52 is going to be the same thing as the probability that the z-score is less than negative 1.75. And the probability of it being less than negative 1.75 is 4.01. And then so we compare. So 4.01% is in fact less than our alpha. So the if the company was telling the truth, the probability of having 150 bars having a weight that was less than 52 would only be about 4%, which is less than 5%. So they're probably lying. And we could be 95% confident that they're lying. So therefore, we make a concluding statement. We say, with a confidence of 95%, we can reject the claim that the mean is 53 grams with that standard deviation. Okay. Let's do another one with the same claim. So the same claim as before. I'm not going to write out the whole thing this time again because I got tired. So the mean is 53, the standard deviation is 7. Our experiment this time is that we weigh 45 chocolate bars and they have a mean weight of 55. So can we reject the claim with a confidence of 95%? Okay. So what do we suspect? So let's draw this thing over here. Whoop. Our mean is 53. Our experiment, I need that blue, was 55. So we're going to have to figure out, we're going to be looking into finding this probability over here. This is the tail probability now. Okay, so we suspect, the alternative hypothesis is that the mean is going to be something bigger than 53. We're not sure what it is, but we think it's going to be that. Okay, so our alpha is, we want to have a confidence of 95%. So our alpha is 5%. The standard deviation, which is going to be the standard deviation over the square root of n, is going to be 7 divided by, and we weigh 45 chocolate bars, so divided by the square root of 45, which is going to be, calculator time, 1.04, which is 1.04. So what we want to know is what is the probability that our mean is, and we want it to be bigger than or equal, but it's continuous, so it doesn't really matter. Bigger than or equal to 55. So we're going to have to turn that to a z-score. So the z-score is going to be 55 minus 53 divided by 1.04, which is 1.92. So what we could write here is the probability that x is bigger than 95, that x is bigger than 55 is going to be the same thing as the probability that z is bigger than 1.92. And the way we find bigger than, it's going to be 1 minus the probability that z is less than 1.92. And the probability that z is less than 1.92. 1.92 is 97.26. Which is going to be 2.74%. So is 2.74% less than our significance? It is. So we're pretty confident actually that the mean is not 53. So we're going to say, oops, I want the nicer red. .74% is in fact less than the alpha. Therefore, we can reject the claim with a confidence of 95. Oh, I went totally off the screen there. So just to recap, in case I went off the screen for that, the probability that z is bigger than 1.92 is 1 less minus the probability that z is less than 1.92, which is 1 minus 0.9726, 2.74%, which is less than the 5%, which means that we can reject it with a confidence of 95%.